We are going to evaluate the line integral of the quantity 1 plus x times y cubed ds, where c is the upper half of the circle x squared plus y squared equals 1. Let's picture this first. The curve C is the top half of a circle of radius 1, centered at the origin, like a rainbow arc sitting above the x-axis. Step 1. Since we're on a circle, we use the standard circle parametrization. Let x equal cosine of t and y equal sine of t. Step 2. We need the range for t. A full unit circle would run from t equals 0 to t equals 2pi. But since we only want the upper half, t runs from 0 to pi. Next, we find dx by dt and dy by dt. Differentiating, dx by dt equals negative sine of t, and dy by dt equals cosine of t. Now we build the arc length term. We need the square root of, open bracket, dx by dt, close bracket, squared plus, open bracket, dy by dt, close bracket, squared. That's the square root of negative sine of t squared plus cosine of t squared, which is the square root of sine squared t plus cosine squared t. By the Pythagorean identity, this equals the square root of 1, which is just 1. This is the built-in shortcut for the unit circle. This square root term always collapses to exactly 1. Step 3. Substitute everything into the integral. We replace x with cosine t, y with sine t, and ds with 1 times dt. So the integral becomes integral from 0 to pi of the quantity 1 plus cosine t times sine cubed t dt. Step 4. Integrate this expression term by term. The integral of 1 dt is just t. For the second term, integral of cosine t times sine cubed t dt. Notice cosine t is the derivative of sine t, so this integrates to 1/4 sine to the 4th of t. So the antiderivative is t plus 1/4 sine to the 4th of t. Step 5. Evaluate this antiderivative from 0 to pi. At the upper limit, t equals pi. We get pi plus 1/4 times sine of pi to the 4th power. Since sine of pi is 0, that whole second term vanishes, leaving just pi. At the lower limit, t equals 0, we get 0 plus 1/4 times sine of 0 to the 4th power, which is 0 plus 0, so that's just 0. Subtracting the quantity pi minus the quantity 0 gives us pi minus 0, which equals pi. So the final answer is the integral of 1 plus xy cubed ds over the upper half of the unit circle equals pi.